Once you clone the Git repo, you'll be at the root of that repo, and you'll want to cd into cd roles, default vars, and then go to the vars directory, and then you'll see basically three files here. You'll see a main.yaml example and a secrets.yaml.example. And what you'll want to do is make a copy of the secrets.yaml example and basically just rename it to secrets.yaml, and then we're going to encrypt that with the Ansible Vault command. So basically we're encrypting it. We'll set whatever password you'd like for that. And then now I'm going to show you an example of what's in the main.yaml file. And I've already populated this based on my environment, but I'll explain a little bit of the different variables that we'll be configuring. So basically, for the forward DNS zone, this is going to be, we have basically two different DNS zones. We have the internal network and we have the external. So right now what we're configuring here is the DNS zone for the internal network. And in this case, it's OCP POC demo.internal, and then basically the reverse zone for the bind configuration is going to be basically in the inadder.arpa format, the reverse 100.168.192. The support server IP, that's basically going to be our gateway, and it's going to perform all the other functions. That's the server that we're currently on. The IP address of that is 192.168.100.1. The support server FQDN, I named this based on my my other environment that I had, but basically right now that's support.callaghan.internal. That's basically whatever you want to call it. If this support server is just going to be used for the one environment, you can basically rename that to be whatever you want. And then for the support server short name, that's just going to be support. And when we configure bind on this support server, what we do is we have a forwarder set up. In my case, we have a forwarder set up to go out to the internet. So I'm just using the Google, the 8.8.8.8 name server. And then the internal IP subnet is basically going to be basically the subnet of the internal network, which is 192.168.100.0, and it's /24. You basically give it the CIDR. It's a class C. The top level domain, in most cases, this is going to be the same as your forward DNS zone, but if your OCP cluster is called something else, a different base domain, you can change that, but in my case, it's going to be the same as the forward DNS zone, which is OCP POC demo.internal. The support IP, the support server IP, the last octet is basically you're basically using the support server IP. You're just giving it the last octet. This populates the dhcpd.com file. Again, your cluster base domain, that's typically going to be the same as well. Usually, like I said, these three values are usually the same. There's some cases where they might be different, but I just wanted to make it granular when I wrote this code. So again, that's OCP POC demo.internal. Your cluster name is basically it's going to be a subdomain off of the cluster base domain. So your cluster name is going to be Ansible.OCP POC demo.internal. So for the next part, you're going to need some URLs in order to download basically the Red Hat Core OS binaries. You're going to need to get the initramfs, the kernel, and the image file. And in order to get basically what I'm getting is the root URL. So basically, in this case, right now when I wrote this, it was still 4.5.6. So what I'm going to end up doing is I'll show you how to get the link to basically the current. We're going to do OCP 4.7 right now. So what we're going to do is we're just going to browse to docs.openshift.com. This is just an easy way to get to this information. So you're going to go to docs.openshift.com, going to go to version 4.7. We're going to go to the installing section, and then we're going to go to installing on bare metal, and then you're going to do installing a cluster on bare metal, and then basically the section we want is going to be where it says installing the OpenShift CLI by downloading the binary. Right here it has a link to the infrastructure provider page, or you can just go directly to this console.redhat.com/OpenShift/create. Again, I'm just showing you this just in case you're not sure exactly where to go. It's always in the documentation. So what I'm going to do now is I'm going to browse. Basically, I'm going to go down to the platform agnostic link, and I'm going to go to user provisioned infrastructure, because that's what we're using right now for this Ansible code. It's basically UPI. So what you're going to do now is we're going to get a couple links here, and what we're going to end up doing is we're going to basically right click on this RH CoreOS ISO, and you'll see at the bottom, you'll see a link. You'll see the mirror.openshift.com pub OpenShift v4. What we're going to do is just copy that link address. We're going to go basically find the root, and what we're going to want to do is let's back this up again all the way to RH CoreOS, and then we're going to see the different version numbers, and again we're concerned with version 4.7, and 4.7.13 is the latest. So this will be our basically the root directory that we're going to populate in our Ansible vars. So let me go back there. The mirror is going to be this, and then we'll basically just want to point these other files are still going to be the same. The RH CoreOS installer and initramfs. You'll see in this. Basically, we have the exact version listed here, but there's also a generic, basically where you can just keep it the same as long as you're in the root of that 4.7.13 directory. You'll be okay. So you got the RH CoreOS installer initramfs, you got the RH CoreOS installer kernel, then you have the metal.raw.gz. These are all going to be downloaded. It's all part of your Pixie boot, and it's basically a combination of Pixie boot, and some of it's going to be downloaded from the web server as well that we're going to stand up. Your gateway IP is going to be the same IP. In this case, my NAT translation happens from the support server, which is the internal gateway. Is going to be 192.168.100.1, and then the OC files URL, that's going to be basically the top level URL for your OCP client. And so to get that, we're going to go back to this website again. Let's just go back up a level. We'll go back to this, basically this link I gave you on the console.redhat.com. And we're going to get, there's basically the OC installer and there's the OC client. We'll actually want to get both. So let's copy the link location. We'll do this, and then let's back up. We're just going to go to clients. We're going to go all the way back to clients. We'll browse to OCP. And then we're going to do basically we're doing 4.7.13 is what the version we're installing. So here you'll actually see the OpenShift client and the basically the installer as well, and you'll want to get whatever platform. In this case, we're installing on a Linux server, so we're going to basically copy this link, the root of this directory. That'll be copied here. In the future, I'll try to keep a link to the latest, OC files URL and the RH CoreOS mirror. I know that process could be a little cumbersome to go through, but that's why I wanted to show you here. The next section basically goes over the settings we need to populate the dhcpd.conf file for the DHCP server. The DHCP subnet, basically, since we're using the 192.168.100 class C, That's going to be the .0 address. The starting IP is going to be, whatever scope you want to define, but I'm basically doing everything after the gateway IP. So I'm starting at 2. I'm going all the way up to 252. Again, my subnet mask is going to be the class C, the 255.255.255.0. Broadcast address for the class C is always going to end in 255. The artifact directory is going to basically have a copy of the install config YAML that's used to basically it sets up your OpenShift cluster. You run the installer against it. And then your core SSH public key is how you're going to SSH into each of the OCP nodes after the cluster is built. You don't normally SSH into them after install time, but during the install, it's sometimes helpful for troubleshooting. There's some things you can do. The rest of these sections, we would leave these commented out because we're not doing a disconnected install. I may do another demo in the future to show these additional features, but there's some stuff that will allow you to clone the registry and mirror it to do a disconnected install. So we're going to save this file now, exit, and now we're going to look at the Ansible, the secret file. So we're going to do Ansible Vault, edit the secrets.yaml. And what you want to do here is get the pull secret that you have from Red Hat, and I provide the URL here. So if you go to cloud.redhat.com, I'll go to this URL. I'm not going to show my pull secret in this example, but I can show you where it's at there. So if you log in here, if you copy the pull secret and just paste it in the middle of these contents here, in the middle of these single quotes, you'll be in good shape. The last part is we're going to go back to the root directory of your Git repo and edit the inventory file. And there's just a few pieces of information we'll need for this. So I already pre-populated this, but what we want to do is populate the full FQDN name for each of your masters. There's basically a host group there for masters, workers, the support server, and also the temporary bootstrap. We'll want to define the full FQDN of masters 1 through 3 and input each of their MAC addresses. And then the IP addresses will be static reservations inside the DHCP server. And then we want to do the short name for them because that's referenced in some parts of the configuration as well. The only thing you want to keep in mind here is for the support server, we'll want to basically have the MAC addresses empty. We're not the support server's currently not getting a DHCP reservation. You just want to define the IP address that's associated with that. And again, the domain, don't pay attention to the domain for my support server. Again, this was used for multiple environments. So that's why I have a name that's different than the rest of the cluster. I will now run through the Ansible code that we need to run. So basically from the root of your Git repo, we're going to run Ansible Playbook. We're going to define the inventory file, which is at the root, which is you do the -i inventory. The name of the playbook is called provision_support_server.yaml. We're going to ask for the vault password to decrypt the secrets, which has your Red Hat Cloud credentials, and then your become pass is basically for our sudo to run root commands against the local server. So I'm going to run that now. I'm going to type both passwords, the sudo password and the vault password, and we're just going to let this go. Right now we're installing bind, and then we're going to configure the forward and reverse zones for bind for the internal network. In the previous video I showed we defined the DNS records that need to exist on the external DNS provider. Since we're exposing this to the internet, this would the DNS server we're deploying here is only for the internal facing side. We're adding the forward DNS zone file. We're creating the basically creating the entries, doing the firewall D configurations. We're creating A records for all the servers, and then the A records for the API, which in this case we're not using the internal side of it, we're using the external, but it still creates it internally. Just in case, you can use it. The scripts, the Ansible code is can work either way. It's also adding CNAME records for the etcd, the wildcard domain. Now we're doing the DHCP configuration, open up the firewall config. We're doing the Pixie server configurations and installing the TFTP server. We'll be enabling that at boot time. That will serve up our Pixie configurations. I'm just installing some of the packages that are needed for Pixie booting. Takes a few minutes to run through all the different roles, but we'll do some verification at the end just to prove that all the configuration changes went into effect. Now we're creating the pointers for each of the MAC addresses to point to the right Pixie config. And now we're installing the Apache server. This will serve up the metal image file. Really nothing special with the Apache configuration. It's just a standard Apache install. I'm just copying, like I said, the metal raw GZ file gets copied to the root of the Apache server. Now we're configuring HA proxy. That's going to front the masters and the workers. So for the masters, we're going to create a listener on port 6443 for the API, and then 22623 for the machine config. And then for the workers, we'll do port 443 and port 80, and that will be for your wildcard. That'll handle your wildcard stuff. And now we're pulling the OC client and the Core OS image files. We're making a copy of the OC client, so that's in our path. So we can run OC commands, and also the OpenShift installer gets copied, and then we have a install config YAML which gets copied to the home Ansible directory. At this point of the install, we basically finished running the Ansible playbooks, and we need to do some manual steps just to install the cluster. So the first thing I'm going to do, right now I'm in the home Ansible directory on my machine. That's where the install config.yaml got created. That was a playbook that we ran. So what I want to do from this directory, I want to make a subdirectory. I'm just going to call it Ansible cluster, and this is, I'm just going to copy the install config YAML to this directory. So now we're just going to verify the version of the OC client and also the version of the OpenShift installer, just to verify that they're at 4.7.13. And this is just taking a little bit of time because there's no, when you run OC version, it typically will do a query against a cluster that's already built, but all I want to do is just see the client version. So I'm seeing the client version is 4.7.13. So So that's good. And then now we're going to just run OpenShift install version. I think it has the same syntax. Yep, 4.7.13. That's good. So the first thing we're going to do is run OpenShift install create manifests, and we have to specify the directory we just created, the full path to it. So we're going to do OpenShift-install space create manifests, and then space --dir equals home Ansible, and we did Ansible cluster. And again, I copied the I copied the install config YAML to that Ansible cluster directory. So we consumed the install config YAML, and you want to make sure you have an extra copy of that, because when it gets consumed by the installer, you wouldn't have it anymore. But since we ran Ansible Playbooks, we could always regenerate it, but it's better to err on the side of caution for that. So let's go to the Ansible cluster directory. We're going to go to the manifest, and we're going to edit the cluster scheduler 02. In this case, what we want to do is we want to set the masters to not schedulable. We don't want to run other workloads on the masters, so we're going to set those to false. And then what we're going to do now is we're going to do the second part of this. Let's go back up to the parent directory, the root. We're going to run OpenShift install create. Actually, let me just do a --help here. I can show you the different options. In this case, next thing we need to do is create ignition configs. So we're going to do shift install create ignition. Okay, it's going to create our ignition files. So now when we go to the home Ansible directory, Ansible cluster, we'll see 3 IGN files. So what we're going to do is just copy them to the root of the Apache web server that we deployed. In this case, I'm just using the standard HTML directory, the var www HTML. And as you'll notice in this directory, I already have the image files and also the metal, the worker IGN, all that stuff. Okay, we're at the point in time now where we're going to start booting up our servers. So I'm going to go in. I'm simulating bare metal with this setup, but it's actually in VMware. But I basically have all the different servers defined inside of VMware. So I'm going to start booting these up one at a time. And I'm going to do the same thing with the masters as well. After we've booted the bootstrap and the 3 masters, we're going to run a couple commands on the OpenShift, using the OpenShift install binary. We basically want to make sure bootstrapping complete. So we're going to run OpenShift-install space wait-4 space bootstrap-complete, and then you want to specify that directory again, the home Ansible cluster in this case. So what happens is right now I'm seeing the API up, which is good. That means the temporary control plane is up, but that's just running on that bootstrap right now, and we may have to wait up to 30 minutes for that for bootstrapping to complete. And basically for the three real control plane servers, which are the 3 masters, they're going to take over control, and in that bootstrap, well, eventually we can remove that, but I'll show you that in the next step. Okay, now we're back. Basically that the OpenShift install wait for bootstrap complete, that ran. Again, you remember earlier where it said the API was up and we had to wait about 30 minutes. Now basically the last message you'll see is that it's now safe to remove the Bootstrap resources. So at this point, basically I can just shut down that, in this case, the Bootstrap VM. But if you're running bare metal, you would shut down of course, the bare metal Bootstrap server. So what we're going to do next is I'm going to boot up the 3 workers right now. Okay, once the workers, give it about maybe 10 or 15 minutes for the workers to reboot and start setting up. What I would do now is we're going to basically export the kubeconfig variable. This will allow us to run OC commands against that cluster that we built. So we're going to do export kubeconfig equals home Ansible, and then Ansible cluster auth, and then kubeconfig. First command I usually run when I'm building a new cluster is I'll do an OC get nodes just to verify that the API is up. And I'm actually seeing the 3 master servers. So again, I've waited about 15 or 20 minutes. What I'm going to do now is I'm going to see if there's any pending CSR requests. So what happens is the workers, when they first join the cluster, we have to do basically a manual approval of the certificates. So in this case, we see basically some pending certificates. So what we would want to do is do OCADM certificate approve, and then basically the ID number or the ID of that certificate. We can actually do a for loop through these all these pending CSR requests. So what we can do is basically I'm just doing for CSR and OC get CSR. I'm getting I'm doing an awk first field, and I'm basically doing an OCADM certificate approve on that CSR variable. So we're just going to run that. So let's see. Let me see if we have any more pending. They all look good. Let me make sure. See if the workers. So now we're starting to see worker 1 show up. And what I'm going to do is I'm going to do another OC get CSR. There's some other certificates that may come in as well. We just have to keep approving them until we start to see all the workers show up. So okay, so we're seeing workers 1, 2, and 3, which is good. 2 and 3 are still showing not ready, but they'll become ready here shortly. Okay, last step after we've given the workers maybe 10 or 15 minutes or so, we just want to check the basically the status of the cluster operators. So what we're going to do is do an OC get cluster operators. And you'll see here, basically you want to ensure that everything is showing available. So authentication, everything's at version 4.7.13. Everything's available. There's nothing progressing. Everything's false and degraded's false. That's good. That's where we want to be for an install. So what I'm going to do now is I'm just going to show you the how to get to the web console. So if you do an OC get routes and then -A, you're going to see the inside the OpenShift console project, there's a route called console-openshift-console.apps.ansible, which is the cluster name we gave, and an OCP POC-demo.com is my external side of this cluster. So if you go here, basically, if I go back in my browser, I'll just put it in here again just to prove to you that it's working. I copied that, and then as that's loading, I'm going to go inside of my home Ansible directory, Ansible cluster. There's an auth directory, and inside of here is a file called kubeadmin password. So all I'm going to do now is copy this password. So now I'm going to take that password. I'm going to go back to our OpenShift web console. We're going to use the kubeadmin username. I'm going to paste that password that we just got, and there's our cluster. So I hope you enjoyed this little walkthrough. Thanks.